paper of the day is Consistency Trade-offs in Modern Distributed Database System Design. To summarize, CAP theorem has been influential in the design decisions of distributed databases. However, designers incorrectly assume that the CAP theorem always imposes restrictions in terms of the trade-offs between availability and consistency. In contrast, the trade-off is applicable only in case of partitions. CAP theorem led to the development of highly available systems with reduced consistency models and reduced asset guarantees. Another trade-off between latency and consistency has also been influential for the database design. The paper unifies CAP and latency consistency trade-offs into a single formulation called PAC-LC. P stands for partition. So in presence of partitions, you can choose availability or consistency, else latency and consistency. Note that some of the observations, especially one about the databases, may be outdated now. The paper was written in 2012. However, the core message is still relevant. So, on latency consistency trade-off. Low latency or high availability means that the system must replicate data. In case of an update query, three possibilities arise. The system can choose to send data updates to all replicas at once. This leads to two possibilities. A replica can receive the update queries in an arbitrary order, thus breaking consistency with other replicas. Alternatively, the replicas could use some protocol to agree on the order of updates. However, this can introduce latency. The update queries can be first sent to a master replica, or the third option is the update query is first sent to an arbitrary replica. This is the same as the previous case, with the query going to an arbitrary replica instead of the master replica and suffers from the same latency issues at the last case. In a nutshell, the trade-off between latency and consistency is always present, irrespective of the network failure. This contrasts with the CAP theorem, which imposes the trade-off between availability and consistency only in the case of network partition. Now, here's the key contribution of the paper. Again, it's the PAC-LC. If there is a partition, how does the system trade off between availability and consistency? Else, when the system is running without failures, how does the system trade offs between latency and consistency? The latency consistency trade off, the LC part, is relevant only when the data is replicated. Default versions of Dynamo, Cassandra, RAG were PA or EL systems. That is, if a partition occurs, availability is prioritized. In the absence of partitions, lower latency is prioritized. Fully ACID systems like VoltDB, HStore, Megastore, and others like Bigtable and HP are PC/EC. PC is partition tolerant and consistent, and EC is consistent, else it is consistent. They prioritize consistency and give up availability and latency. MongoDB can be classified as PA/EC system. Again, what it means here is in the presence of partition, it could be available. You have a choice between availability, else consistency. While Peanuts is a PC/EL system. That is, in the presence of partition, you can pick consistency or else latency.